welcome back. Hope these are working out for you. We have different problems and a lot of them, so it's easier for editing purposes if I just break them up. Okay, we're going to look at a new problem, and here it is. Perimeter of a rectangle is 64 inches. Find the width, which we're going to call x, and the length, which we're going to call y, to find the largest area. Okay, so let's draw a rectangle. Okay, now what do we know? Oh, that's a messy rectangle. Let's do that one again. All right, let's draw a rectangle. Okay, what do we know? Perimeter is 64 inches. Find the width x. So we know this is x and the width. And the length we're calling y. Okay, we're trying to find the largest area. So they give us two things here, as you notice. They gave us perimeter and area. So once again, we're using two separate functions that we're going to utilize together to make up one. Okay, so we know the perimeter is going to be 2x plus 2y. We also know the perimeter is 64 inches. So 64 is 2x plus 2y. All right, now what do we know about the area? The area is length times width. In this case, we'll just xy. All right. Find the width and the length to find the largest area. So we want to find area altogether, but we have an x and a y. We can do something to this so we have only one variable. All right. So let's solve for y on this variable. For y, excuse me. All right. So we're going to minus 2x from both sides. 64 minus 2x equals 2y. All right, we got the 2x on this side. Divide by 2 for everything. So divide this by 2, this by 2, this by 2. And we end up with y equals 32 minus x. All right, that's great. We found out what y is, so now we can apply it to the area. So we're looking for y in this case, right? Y equals this in terms of x now. So our function is going to be a of x equals x times what y is. And y is 32 minus x. Okay. So again, we're looking for the largest area, so we want to take a prime. Before we take a prime, though, let's go ahead and distribute this. We have 32x minus x squared. All right, so a prime is going to be 32 minus 2x. Okay, set that to 0. Solve for x. X equals 16. Okay. Now let's look at a double prime. A double prime x. We take the derivative of this right here. We just get negative 2. And negative 2 is less than 0. So if it's less than 0, it concaves down. So we're going to have a relative max at x equals 16. Okay? Relative max at x equals 16. Okay, so I'm going to erase this and we'll continue. Okay, so we said x equals the width, and we just found that the width is 16 inches. All right. Y equals the length, and we found the length was 32 minus x. So that's 32 minus 16, which is also 16 inches. So now we're looking at a square. Okay. So the maximum area is going to be 16 times 16, which you could figure that out. Inches squared. Okay, we have a new problem. Cost of a fence, enclosure, we're looking at 400 feet squared. Now this one's a different one, where neighbor pays for 1/3 of one side. Okay, assume $1 per foot. Find the length and width. If you're wondering about that water in the background, I have a fish tank. Okay, cost of a fence enclosure, that's 400 feet squared, where a neighbor pays for 1/3 of one side. Assume $1 per foot, find the length and width. Okay, so we're going to still use that same rectangle before. I'm going to call this Y, this X, I don't know, just because I want to. All right, and here's our little neighbor. Okay, the neighbor's going to pay for 1/3 of this fence. Okay, so we have cost is we have 2 Y's plus this X here. Now, since they're paying 1/3, we're going to pay 2/3. Okay, so the cost is going to be 2Y plus 1 2/3, which is 5/3 X. Okay, now they gave us cost. What else did they give us? They gave us somewhat of an area. So we know area is X times Y. All right, and they gave us 400 feet squared. So we're going to utilize that. All right, so solving for Y, Y is 400 divided by X. Okay, so now what we're going to do to find the cost function, we're going to substitute this Y into this right here. So we have all X's that we're dealing with. Okay. All right, so what would we do from here? Well, we're going to simplify, and then what else we're going to do? We're going to find the derivative. Okay, so simplify that, find the derivative of that, set it to 0, and I'll let you do that on your own. And we find out that X is approximately 21.91 feet. Okay. Find the length and the width. Well, that's not hard to do. We have the length here, so what would we do next? We'll put this right into here, and we'll find the dimension of the other one. So you can do that on your own. Okay, next video.